All right, well, hello again, everyone. I am Mr. Santos, and in this video, we're going to talk about PCB layout and routing using OrCAD PCB Editor, version 16.6. If you recall in the introduction of the video, we talked about how a PCB project endeavor is divided into two predominant phases, which I just called phase one, which is where you do the schematic design in Capture CIS, and I said that that might entail other things such as creating your own custom symbols and whatnot, and we needed to assign footprints to all of the components in our schematic, and then as a very last step among the many steps that we took in that video, the final step was to generate the netlist file. Okay, which OrCAD calls a board file, .brd file, because the file contains basically a list of nets of what is connected to what. Okay, and we need that file. We need to successfully generate that file in order to begin doing the PCB layout and routing in the PCB Designer, PCB Editor. I'm going to be using these terms interchangeably, PCB Designer, PCB Editor, for OrCAD product. So if you recall, here I have pulled up what the schematic that we did in those videos. Several videos were created surrounding many aspects of this particular design to get to familiarize you with many of the aspects of using the tool. Okay, so let me just go into my project folder where I had my OrCAD tutorial, and I said that we have, when we generated the netlist, it was created in a folder called Allegro, and inside of the Allegro folder was our OrCAD tutorial.brd. That's the file that we want. That is the file that we need. It's a very important file. So before I do anything, the very first order of business is to make a backup copy. Control, paste, and I'm just going to call it backup _ backup, so that if something goes wrong, if you experiment around and you need to go back to a known state, you can go back to your original file. Of course, you can always regenerate the board file from your schematic provided it hasn't changed. But I normally like to do that. So notice that right now there's just some very few files generated in here, nothing much, nothing else going on. But as we progress through the to this task of working with the PCB phase, the number of files will grow. Okay, so let me just pull up. I have OrCAD PCB Designer here already opened up with another project from another student that has been done in the past. And I have this pulled up because I kind of want to give you a quick tour and show you, talk about a few things regarding the interaction, the user interaction experience when it comes to using OrCAD, which is not, it doesn't feel very natural at first, and this is a source of of adding many of the things that add to the steep learning curve when using this in comparison to using the schematic OrCAD Capture Schematic portion. And then after that, we'll go ahead and we'll start from the beginning from our actual project. So what you're looking at here is actually a different project from another student, but I want to give you a quick tour. So the thing about OrCAD is that, if you recall, and I had mentioned this in the previous video, that the schematic editor, OrCAD Capture, is very intuitive, very simple to use. Everything makes sense. You can press the W key if you want to lay out a wire. If you want to add a net label, you just hit N. If you want to add a no connect whose symbol is a cross or an X, you just hit the X key. If you want to cancel an operation, you hit the escape key. If you want to lay a bus, you hit the B key. You want to copy, you Control C. You want to paste, Control V. We expect these things from typical software, but for OrCAD, with Core PCB Designer, everything is not very intuitive. You have to. It's just different, very different, and that's the part that we have to first get through. And I want to show you some of these things so that you're aware of them as we are actually working on our very own project. So let's just go ahead and get started here. So here is OrCAD PCB Editor, and it's open, and we have a variety of tools, and the main thing that I want to show you right now is basically how to work with with some of the basic tools, like moving stuff around, copying stuff around, deleting stuff, how selection works, things like that, which are very different. So let me just give you a quick tour here. So initially, so here's the design area, all right? And of course, the design area is where you see your design and where you lay out the parts and lay out the traces. Okay, my middle mouse, the scroll bar, if I scroll up, I can zoom in into the design area, and if I scroll out, I can zoom out of the design area. Okay, if I push the middle mouse button and hold it, I can actually pan around my design area. In addition, you can use the arrow keys on the keyboard to pan around in discrete steps. Okay, so that's that. Along the top, we have a variety of icons, some of which are very significant, some of which are not quite. If we want to move anything, we have to enter a move mode. If you want to copy, we have to enter copy mode. If you want to delete something, we have to enter delete mode. Okay, in OrCAD Capture, many of the tools are actually persistent. That means that you have to enter the tool first, all right, and then after that you can manipulate any elements using the particular tool, and the tool remains persistent until you actually exit the tool. Okay, so let me give you an example. Let's say I want to move stuff around, so I want to go ahead and I can either hit move here or do shift F6, and I'm going to be using the shortcuts a lot. So shift F6, and I'm now in the move mode. And the reason you can tell that I'm in the move mode is that if you look in the left hand corner of your screen, you're going to see it says move. Okay, so if somehow you forget that you are in the move mode and you decide to do something with the mouse and OrCAD is behaving strange for you, maybe take a look at if you have any tool engaged. Maybe you still have not exited the tool. How do we exit the tool? Well, there's 3 keys. You can either right click, and notice that you have these 3 commands. You have done, F6, oops, F8, and cancel, F9. When you have made any changes using a particular tool, such as moving stuff around, and you are done, you hit done. And F6, that means that you commit the changes that you made. If you start making a motion, you move a part, but then perhaps you say, oh, I didn't mean to move that part, it was a different part, but you don't want to exit the tool, then you hit F8 for oops. If you want to exit the tool and you want to cancel usually the last edit that you have made, then you can hit cancel, which will undo the previous change that you made, but it will also exit the tool. Okay, so these 3 behave differently. And again, I try to memorize the shortcuts. So we have F6, F8, F9. All right, so I might use any of the 2, but let me just demonstrate. So right now, I'm in the move mode. And so as I hover my mouse, notice that the parts will highlight accordingly. But usually, if I click on the component, the component will attach to the mouse, and usually it will attach under pin 1. Whatever pin 1 tool is designated, it'll attach to that. Notice that as I have still the component under my mouse, I can scroll in and I can scroll out using the scroll bar to zoom in and zoom out. And in addition, I can also pan around. If I hold the scroll bar button, I can pan around while I'm still holding the part. Okay, if you want to place it somewhere else, you go ahead and you click on it again, and the part will be placed. Now, if I didn't mean to move that part, and maybe I meant to move C1, I go ahead and I do a oops, and then it goes back to under my mouse because I still have not finished that motion. Okay, if you do oops again, it'll now put it back to where it was originally. And then I'm still in the move mode. Notice that I have not left my tool, so I can go ahead and grab another thing. And if I did not mean to move that part, I say nope, not that one. But then say I do move it, and I click, and now I have made one edit. I can go ahead and cancel, and then the part will go back to its original position. But notice that my move, I'm no longer in the move tool. I have exited the tool. Okay. Let's talk about delete. Say suppose I want to delete a part. Of course, it would have been nice if I could just select the part and click the delete key, but that doesn't work. Usually you have to say Control D to delete to enter the tool. Control D, And notice that now I am in delete mode, so I can click on the part once it's selected. Oh, you know what happened? I think I had a, let me exit it, cancel. Let's do, I'm clicking here in an empty area to deselect everything. Control D. Oh, I know what's happening. Let me grab your attention here. Notice here I have this panel called Find. I wanted to talk about this later, but now I'm forced to talk about it right now. You see the Find panel. You see all these boxes. This allows you to control what is selectable with your mouse pointer. Right now I have connect lines, and that's why as I hover my mouse over any of the parts, nothing is selectable. Okay, this is actually very useful. You can sometimes there are many design elements that are on top of other design elements, and it's difficult to select a particular design element, and this is what this is for. If I click everything on, then everything is selectable. Notice that now any component, the reference designator, the components, the pins are all selectable. If I turn everything off and say I only select text, then only text is selectable. And only select text is editable. I can move text around. Okay, so keep that in mind. While we are on this panel, since we are forced to talk about it right now, notice that these are usually hidden. So what you will find is that when you open OrCAD Capture for the first time, you'll have these three visibility, find, and options, and if you hover your mouse over it, the particular panel will reveal itself. But I normally recommend that you pin these so that they're permanently visible by clicking the pin button there. Find, pin it, visibility, pin it. Okay, and then for the visibility, we can usually lower this all the way so that we can use as much of this as possible. Find, we can adjust it. That way we can see options as much as possible. Anyways, I want to turn this on for all so that I can select any component, any element. And then lastly, let me draw your attention onto options once again. Okay, what shows in here depends on the mode that you are in. Presently, I'm in the the delete mode, and therefore these are options for my delete. Okay, that you can enable or on off. Anyways, deleting. I wanted to delete. Let's say I wanted to delete this part. I'm in delete mode. I go ahead and click on it once to select it, and then I click on it again to let it go. Okay. You can do Control Z to undo, which is the same as doing an oops. Actually, it's the same as doing a cancel, because notice that my delete mode has exited and terminated. If I want to enter the delete mode again, Control D, and I want to delete multiple parts, I can actually drag around to select the parts first. Once again, my delete has, let's do all on. I can select all the parts first, and they select, and if I want to delete the part, I just click anywhere, and then the parts will disappear. And if I did not want to do that, I go ahead and do an oops, and notice I'm still in the delete mode. Okay. Once again, never forget to exit the tool. Right click and do a cancel or a done once you're satisfied. Let's talk about copying stuff. If you wanted to copy something for whatever reason, you go ahead and hit Shift F6 or click the copy icon here. F5, sorry, Shift F5. Alright, so if I do Shift F5 with no component selected, I can go ahead and select this and click on the component, and it makes a copy. And I can go ahead and duplicate this and click to place it. And I can make another copy and click to place it, etc., etc. If I did not want to do that, I just wanted to show you, I go ahead and cancel. Notice that when I enter the copy tool, my option panels allows me to control various ways in which I can copy and paste. Okay, but this is you can look this up in documentation if you want more details. But anyways, done. Okay, what else I can show you? Moving stuff around. So again, more about move. Shift F6 to enter move mode. Once again, I can click on something to move it. Notice that my options panel over here allows me to various options for move. If I want to rotate this part, which I sometimes want to do, I can right click while I have my component attached to my mouse pointer, and I can hit the rotate. Okay, if I move away from pin 1, okay, this is 0 angle, I can go ahead and rotate. Notice that my rotation is constrained to 90 degrees. right? If I do oops to cancel rotation, notice that I'm still moving the part, and I do another oops to let go of the part, I'm still in move mode. I can go here in options and I can change the rotation restriction to 45-degree increments. I can go ahead and click on the part. I can right click the part. I can enter rotate, and now I can rotate in 45-degree angles. Okay, once you're happy with whatever form, I can go ahead and just call it done. Let's see, do I have to click? Yeah, you have to click. So let me rotate again. If I want it that way, you need to click to commit to rotation. Notice that I'm still in move mode now. Now I'm in translation mode. I click on it to commit that, and then you finish, and it's done. Okay, let's see. If I do Control Z, I can go back to that. Let's see what else I can show you. Again, we're just doing a tour of what you will see. Notice that this board has an outline, and we will show you how to do a board outline, and it also has a designated keep in region. This means that all components must be placed inside the keep in region. If you place a component outside the keep in region, you will get a design rule check error, and you will be notified of that. Okay, notice that every board has a designated origin, right? Once we have drawn the outline of the board, manufacturers, many PCB board manufacturers ask that you designate the origin of the board in the bottom left hand corner, and I will show you how to do that. And this design has it designated in the bottom left hand corner, which is designated as 00 coordinate. If we look down on the bottom of the screen, we have the current coordinates in the current units, which is either millimeters or mils, and mine are in mils at the present moment. Okay, if the tool is busy for whatever reason, this will show you whether it's busy or not. When it's green, that means it's not doing anything at the present moment. We can change the coordinates between absolute and relative. Okay, so for example, if I engage the absolute mode and I click on it, I temporarily designate that coordinate as 0, 0. Okay, let me just try that again. If I click, let me click here, it'll designate as 0, 0. And I hate that. It's showing that tooltip and you can't see it. Okay, 0, 0, and then it'll show you just relative to the previous point. This will actually be more useful if I could have a direct straight line distance measurement as well, but it doesn't do that. Anyways, let's go back to relative. We may talk about this later. There are 4 application modes in which you can operate OrCAD, and these modes are actually selected by these 4 icons, which is general edit mode, and that's usually the mode we will work in. There's the part placement edit mode, there's the etch or trace edit mode, and signal integrity mode. Sometimes selecting the mode will allow the right mouse context menu to be populated with tools with options that are specific to the particular task. So if we're in placement mode, the right mouse button will give me options that are more specific for placing parts. And if I'm in the etch edit mode, then the right mouse button will give me options that are more specific for laying out the traces and editing traces and whatnot. But mostly you want to make sure we're in the general edit mode, and depending on what mode, you can see it down here. Okay, here is the world view, and basically that shows you, as we zoom in and zoom out, and we pan around, this should kind of reflect changes on our design. Here. You don't see that happening probably because my video capture application may be interfering with that task. To the right we have DRC, and that's going to be green where we don't have any errors that we may set up depending on the rules, and if there's some errors on the way, then the DRC might turn right. For example, suppose that I choose to move this part, Shift F5, and I move this part, oops, that's a copy. Let's cancel. Shift F6. I move this part out here, and notice that now I have an error. My DRC marker has shown a violation, and if I go here up to display status and I do update DRC, notice that I have sort of a warning here of a minor error that we need to take care of. Sometimes it won't reflect here. Let's see if I do a refresh. It depends. Again, I think that my motion, my video capturing tool, it might be interfering. Let's go ahead and move that back. In fact, let's do a cancel. Let's do undo. Control Z. Nope. We're gonna have to move it. Shift F6. Hit it, and let's put it in there. Okay, these lines here are rat lines, or rat's nest. All right, and basically the blue lines indicate what is going to be connected to what. Okay, and they guide you. Basically, you will need to add a trace between this pin and this pin, between this pin and this pin, or however you like. But you need to take care that all of the traces, all of the rat lines are eliminated by way of adding traces to the board. Okay, let me draw your attention to some other things. The grid, you may need to toggle it on and off, and the shortcut for that is F10. All right. The grid will change depending on what you're doing. If you're only moving parts, then the grid will move into the to a different setting. If you are laying out traces, the grid will change to a finer resolution. And I will show you how to set the properties once we start doing our own project. Okay, color dialog. Let me turn the grid off. Color dialog panel. Color dialog panel. This is confusing because you think about a color dialog and you think about editing, basically customizing the color of your user interface. But this is a poor name for how important this particular panel is. In fact, color is the least important component right here, so I'm actually going to hide the palette. What is important about the color dialog is that it actually controls the visibility of various attributes of visible elements on your design area. Okay, and you can turn stuff on and on, and what can be turned on, stuff on and on, depends on, it's categorized by classes. All right, if you want to talk about the board geometry, for example, the outline is part of the board geometry. We can actually hide that. If I click here, the outline, and undo that, and I click apply here, notice that my board geometry disappeared here. And that's just for the geometry. If we look at for let's see, areas, right? We have here a key pin area because it's purple. This is a key pin area. If I hit on key pin area and I uncheck that and I click apply, now the key pin area disappears. So now I have a package key pin area. I eliminated the package key pin area. So that means if any component part is not within it, I'll get an error. Okay, but this is just about visibility. And then there's another area beneath the keeping area, which is called the routing keeping area. So that means that once we start laying out traces, the traces have to be inside the routing keeping area. So you can have multiple areas that control different aspects of what should be in or not in a certain area. That's why we have two separate areas overlapping. If I click apply, notice that it disappears, right? So let me engage that, apply. Let me go back to board geometry, outline, apply. Let's go to components. This is actually very important right here. Components usually have several pieces of information. This is component information. We have component value, we have device type, we have reference designators, we have tolerance, we have user parts. By default, when you start a new OrCAD project, you will actually have all of these enabled. And if I click apply, notice that you have a bunch of information that is replicated and duplicated, which clutters our design. And we do not need any of this stuff. This is for informational purposes and for generating alternative layers, which we are not going to need for the purposes of generating a PCB. When we have a printed circuit board, the only thing here that we usually need is just a legend with the that's not a very good one. Let me find another one here. Let's see, view image. Okay, we have the white marking, the white paint. That's called the silk screen. Okay, and the only thing we need is something that gives us an indication of where the component goes and how it is oriented. and perhaps its shape and size, and also the reference designator. Let me find a different image here. I want a nice close-up. Here we go. Let's see, view image. Perfect. All right. So we have a legend paint on the seal screen, and then we just need the reference designator like R114, R81, R80, R87, R15. The component value is not quite as important. This seems kind of overkill, but there's nothing wrong with that. But usually you just need the marking for the components so that you know how it is oriented. For example, notice that the dial shows you where the cathode goes, and we need also basically the reference designator so that we know which part we're supposed to place in the component in the board itself. That's all we need. So we don't need all this information. And so the way to control that is that first you turn everything off. And then again, the only information we want is the information that goes on the seal screen layers. And we only want the component value for the bottom seal screen layer and top seal screen layer, and the reference designator for the bottom seal screen layer and the top seal screen layer. We hit apply, and notice that when I dismiss this window, notice that now I have a very clean, board with information. And then usually what you want to do is that you want to start grabbing the text. This is where we would probably go to all off here under Fine and just select text. And then you want to align let me exit the tool. You want to go ahead and grab the text so that it's outside and place it so that it's outside of the component. You don't want to place any text or component designators inside of the component, because once you place a component on top of your board, you're not going to be able to see this information. This is important also after the board has been assembled. So we have U3, which belongs to this, and the component value, which belongs to also this, maybe down here, etc., etc. You need to beautify this after you're done. Okay, so that's the color dialog, very important. The other thing we need to do is when you start a new project is we go into the cross section or the Stackup panel. The Stackup panel allows you to designate how many layers your board is going to comprise of. Basic boards comprise of 2-layer boards, so therefore we need a conductor, okay, a copper conductor layer, and then there's the dielectric, which is basically the prepreg part. Is like a fiber type of which the board is constructed of, and then the other side. If you wanted to make a 4-layer design, you can just go here and then you can add a layer above or below. So for example, if I add another layer, then you can designate this as a dielectric. Let's see, we would need conductor, dielectric, conductor, dielectric. We need another layer for conductor, another layer for dielectric. So we would have a dielectric here and here. And here maybe with 4-layer designs we would usually have like a plane, and then here maybe this could be the power plane, and this could be the ground plane. Okay, so this is where you would go, and usually you can ignore all of this. As a minimum, you just should designate the number of layers, and then you would hit apply. But again, I'm going to hit cancel. But just know that the cross section here is where you set up how many layers your PCB design is going to comprise of, and it's already set to 2, so I don't need to do nothing there. The other panel that you need to be aware of is the constraint manager. Before you start laying out traces, this allows you to set various constraints, such as what is the minimum width of a trace for all nets. Okay, right? I can either go on a net by net basis and set what is the minimum line width, and there's some other attributes here that you can set, and you could apply it to all the nets in your design. Notice that the minimum line width is 5 mils. That means if I make a trace that is thinner than this, I will get a design rule check error. And the reason you will want to set this is because manufacturers, PCB manufacturers, they have their minimum restrictions that you must follow. A manufacturer will tell you no copper feature can be smaller than 5 mils, or if you maybe they might have a student pricing restriction. So if you take the student pricing advantage, maybe they'll restrict the minimum feature size to 7 mils. So that means that no copper feature can be smaller than 7 mils. And therefore you should change these accordingly such that the minimum is 7 mils. And we will go through all of this later for our own actual. Right now I'm just giving you a tour. Okay. Then there's the spacing. What is the spacing between two adjacent traces that may be of different nets? And again, a manufacturer might specify no copper feature can be close to any copper feature by 5 mils or 7 mils, etc. What is the spacing of a net to itself? So if I coil a copper trace around itself, how close can that be? All right, once again, you can set the minimum line width, etc., etc. Properties. The most important thing under properties, under general properties, is that you look at your nets, all the wires that you will have to connect, and you look under the no rat column. And usually, for whatever reason, the no rat will be enabled for your power lines. That means that when you're looking at this, notice that my power pins don't have rat lines showing me that I should connect these. And that can mislead you into thinking that you're done after you've done everything else, and you're not. So you need to make sure that these are never in the on position. Okay, we want to see all the nets. Okay, information. You can actually hit F4 to show an element, and we can go ahead and find something about an element. So if I engage the information tool, you have to select it first. So if I want to know something about that pin, that pad, I can hit the information, and it will tell me information about that pad, such as what is the pad stack name. The pad stack is the file that comprises this pad stack. Okay, and the hole diameter. It tells me that the diameter is 36 mils, okay, and its location, etc., etc. Okay, the other thing is the measure tool, right? Shift F4. So if I hit the measure tool, I can click here, and I can click here, and I can find out what the distance is. 100 mils between these two, and it'll also tell me what the it should tell me what the drill diameter is, and it's 36 mils on both holes. So that information is also presented here. Okay, so note that. Okay, the rest I'm going to show you. Oh, there's one more thing I want to show you. Is basically the command tool. This is for using OrCAD in expert mode, and this is where the true power of OrCAD is revealed. You could basically, almost every command in here can be entered as a command in here in the command window, if you know what the commands are, and you can enter those there. So you can set up the grids, you could show specific nets and hide specific nets, you know, all these lines, etc., etc. You could do it here, but that's beyond the scope of this tutorial video, so we're not going to show that. Let's see, last thing is the artwork control form. When we are done, when we have completed the PCB project, the artwork control form is accessible by the camera icon. And in this particular project, student has 1, 2, 3, 4, 5, 6 layers that he wants to generate as Gerber files. And we have to do this ourselves, and I will show you how to do that. But in the end, once we are done, the goal is to generate those Gerber files, and to do so we use the artwork control form. Okay, but again, we will cross that bridge when we get to it. But that concludes the tour. So let's go ahead and now begin working with our project, which is our 3-bit, and we're going to show you the entire procedure from completion to finalizing it, and then maybe the generation of the Gerber files will be left as a separate video, because it's just going to be way too long, and there's no way around that. This is where the real challenge of using OrCAD really begins. That's when we're using the PCB. There's just so much to discuss, and there's just no way around it. So Let's go ahead and get started with that.